Good morning, Geometry iPad Initiative students from OHS. This is Mr. Lane again. Today we're going to be discussing section 3.2, which is over angles formed by parallel lines and a transversal. So it's going to go back off that prior knowledge from last section. A lot of those angles now are going to be the same types of angles, but there's going to be a relationship between them now that there's a parallel lines that is cut by the transversal. Hopefully you remember what a transversal is from the last section, and hopefully you probably already know what parallel lines are also. So again, you're going to have to do the number 5, answer it in your notes with your half a page of notes and your summary, and make sure you send that to me for your points on that. A little bit of review from the previous sections. It's kind of a cool little page here. Basically it allows us to drag this over and we see corresponding angles, what those were from the last section. And again, if we drag the vertical angles are, well, we see an example of what the vertical angles are. So that's kind of cool. Then alternate interior angles, little stars represent that again, and the alternate exterior angles. By dragging that over here, we can see an example of those. So there's also same side interior angles, which are not on there. Let's move on over here. We got the first little postulate, which is the corresponding angles postulate. It says if two parallel lines are cut by a transversal, and you'll probably hear me read that quite a bit during today's lesson, so all of your postulates and theorems are going to start off that way. Then the pairs of corresponding angles are congruent. So I got a little diagram down here, and it wants us to name the angles congruent by the corresponding angles postulate. So let's just name a few of those real quick. You could probably already name them all, but it looks like angle 1, remember corresponding angles is at the same location of the other intersection, so angles 1 and angle 5 would be congruent because they're corresponding angles. Let's pick another set out here. It looks like angle 2 and the upper right hand corner of that intersection would be angle 6, so I could say that angle 2 would be congruent to angle 6, like so. And we could go on and on a couple more times anyways. Angle 8 here would match up with the lower right hand corner of this intersection, which is angle 4, so we could say that angle 8 would be congruent to angle 4. So let's go on to the next page. If you need to rewind that and listen to it, feel free. I think we got an example here that uses corresponding angles to figure out what some of the measures of different angles are in the diagram. So looking at this, I see that I've got a couple of corresponding angles that is marked with a expression when using the variable of x. So if those two are corresponding angles, given that these two lines are parallel, cut by transversal, I don't know, we could call that BE, then I could say that these two angles would be congruent. So I'm going to say that 4x plus 22 equals 5x. Remember, congruent means that they have the same measure, so their two measures are going to be equal. Well, from here we just want to solve it for x, so I'd probably go ahead and take that 4x over to the other side by subtracting it. Subtraction property of equality, if this was the last section or last chapter. So those would add out, and over here it looks like I would be left with x equals 22. Well, we found out what x equals, but in order to figure out what the measure of these angles are, let's see, ECF, must not have marked F here. Maybe F is supposed to be right down here. So ECF would be this angle right here. Well, notice that it's corresponding to the 70 degrees. So this angle would just be 70 degrees. I didn't even have to find x for that. But then it says the measure of angle DCE, which is the 5x right here. Well, I'll need to plug in that 22 in for x, so I'd have 5 times 22. If I do that calculation real quickly here, I would get 110 degrees for the measure of angle DCE. So let's carry on to the next page now. Regular geometry class students would be doing problems 2 and 6 from page 157 at this point. iPad students, yours is always at the end of the section. Let's see, I've summarized the angles throughout this chapter, this section on this page here. Remember that the relationship of the angles only holds true when we have two parallel lines cut by a transversal. But if we have that situation, the corresponding angles are going to be congruent. Alternate interior angles are also going to be congruent. Alternate exterior angles will be congruent, where the consecutive interior angles, or that's also called same side interior angles, so I'd write it down as your same side interior angles, are going to be supplementary, which hopefully you remember supplementary adds up to equal 180 degrees. So let's move on here, and I do go ahead and write the other theorems. Remember we had the corresponding angles postulate that we had on the other page, but now we have the actual alternate interior angles theorem, which says that, again, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Same thing with the alternate exterior angles, they're going to be congruent. And the same side interior angles theorem just states that if the two lines, parallel lines, are cut by transversal, then the pairs of same side interior angles are going to be supplementary. So make sure you make a note of that in your notes so you have it. And we have another example right here on this page. So we got to find x and then find all the 8 different angles that are here then. And we should know enough information now to solve this a couple of different ways. So let's just try and pick out some angles and get started here. Looks like I could go with the corresponding angles. So I could set those two equal. There might be another way that you could also solve this, which might be a little bit easier. So you might explore this a little bit, because they'll all turn out the same no matter which relationship that I decide to use. So let's see, I need to take the x's on the same side, so I'm just going to subtract the x from this side. So the x's will add out here. I'm going to drop that negative 30. Make sure that you don't forget that negative sign there. That's a pretty common mistake. So we'll have x here, drop the minus 135, and change colors here and extend the page. Now I need to take the 135 over, so the opposite of subtracting 135 would be to add 135. So we're going to add 135 to both sides. Adding the 135 out over here gives us x right here equals, looks like a 105. So now that we have x, it should be pretty easy to figure out what all these angles are. Looks like 105 for this angle right here. That is just x. Alright, let's figure out what 105 minus the 30 is to give us the angle right below that. So I'll take 105 minus 30. There's some bad handwriting there. And that's going to be, 75? So notice that the alternate exterior angles would have gave us 75 for that also. Let's see, these are vertical angles right here, so I know that this is going to be 75 degrees. Vertical angles are congruent. And then let's see, corresponding angles would give me this top angle as 105 degrees. Vertical angles right here would give me this as 105 degrees. And then all I have to do is match up the corresponding angles. So this one would be corresponding to that upper right, which is 75 degrees, and this bottom right one would match up to the 105. So this one would be 105 degrees. So once we have basically one or two of these angles, it's real easy to find the other angles. So let's move on here. The regular geometry students would be doing 4, 8, and 10 from page 158 at this time. But we're going to continue on here. Let's see, we got another example here. Now we've got three parallel lines. Looks like we've got a couple of different transversals that are cutting those parallel lines here, and we're supposed to find X and Y and then find the angles that are marked after we find the X and Y. So we need to decide what kind of relationships that we have in this. Now it looks like I'm going to kind of just forget about this middle one for a second here. So I'm just going to cover it up. And also we really don't need that bottom transversal either, so let me try and cover it up if I can. It's going to be a little tougher to get that one. Let's see, that should work. There we go. So all I'm really looking at are these two parallel lines and these two angles. Hopefully you recognize those as alternate interior angles. So I'm going to go ahead and put those two equal because alternate interior angles are going to be congruent. So I'm going to put 55 degrees equals 5x plus 4y. Alright, now I'm going to still keep that one covered up here. Actually, I'm going to move this and cover up this because now all I'm concerned with are these two parallel lines and these type of angles. Well, those are corresponding angles right there. So I'm going to write its equation as 60 equals 5x plus 5y. So it looks like we've got a system of equations that we have to solve here. Hopefully you remember on systems of equations we've got a few methods that we can use. We can either use substitution or elimination or graphing, but graphing wasn't very accurate, remember. So I'm going to set this up for elimination because I've got both x's and y's right on top of each other and it equals the constant on the other side. So all I have to do is obtain opposites on one of either the x's or the y's, and the real easy way to do that, it looks like, is if I just multiply a -1 all the way across, just changing the signs of every single term in this second equation here. Now notice that I'll have opposites right there with the x's. So I'm going to go ahead and cross those out and just add straight down. So I'm going to have -5 equals a -1y. So I have to divide by -1 on both sides to figure out what y is. So it looks like y will equal 5. Now I'm going to have to choose one of these equations to plug that y value back into to figure out what x is. So I'm just going to take that first top equation there. I'm going to write 55 equals 5x plus 4, and then that's going to be times my y value of 5. So to simplify, I'm going to have 55 equals 5x plus 20, and I have to take the 20 over to the other side, so I'm going to minus that 20, which is going to leave me with 35 equals 5x. So if I divide by 5, it looks like I'll have x equals 7. So now all I have to do is plug those back into my two angles that I'm missing there, now that I have the x and y values, and I'll figure out what the two angles are equal to then. So let's go with a little blue here. So if I plug 7 in for the x here, I'll have 7 times 5, which is 35, plus, plug in the 5 in for the y, I'll have 4 times 5, which is 20. So 20 plus 35 would give me this top angle here as 55 degrees. Okay, this bottom angle, 7 times 5 again is 35, plus 5 times 5 is 25. So if I add those together, it looks like that angle would be 60 degrees. So I'm going to go ahead and stop part 1 of this video. There might be just a little bit left for a part 2. So thank you. This is Mr. Lane signing off from OHS High School.